Let's talk about Starship. Look, we all know it's the most powerful rocket ever built, but it's so much more than that. This is a totally reusable transportation system, and it was designed for one single audacious goal: to make humanity a multi-planetary species. So in this explainer, we're going to break down not just how this incredible machine works, but why it represents such a massive shift in how we think about our future in the cosmos.
For as long as we've looked up at the night sky, Mars has been that little red dot calling to us. It's been this beacon, right? A symbol of the final frontier. It's a world that has fueled our myths, our stories, and of course, our scientific curiosity for centuries. It's always been the ultimate dream.
But what if we've been looking at it all wrong? What if becoming a species that lives on more than one planet wasn't just about the thrill of exploration, but about straight-up survival? Now, that question, that changes everything. And it's the real motivation, the core reason that Starship even exists. And that is where Starship enters the story. So we're going to look at this thing not just as a magnificent machine of stainless steel and fire, but as something more, as humanity's potential lifeboat, the proposed answer to that massive existential question.
Okay, so let's start with the most basic question of all. Why? Why go through all this incredible effort, all this expense? What's the real driver behind this almost unbelievable goal of building a city on another planet? Well, the primary driver, the big idea here is to create a backup for humanity, a backup for consciousness. Look, Earth is amazing, but it will eventually face an existential threat. Could be an asteroid, could be something we do to ourselves. Starship is really being designed as an insurance policy.
All right, so we've got the why. Now let's dive into the how, because the engineering behind Starship is it's a completely radical departure from everything we've done before. And it all begins with its absolutely mind-boggling scale. So when it's fully stacked, the whole system stands at a colossal 123 meters. That's over 400 feet tall. To put that into perspective for you, it doesn't just stand next to the Statue of Liberty, it completely dwarfs it. This is not just a small step up from the last rocket. This is a whole new category of vehicle. And of course, that size is matched by its power. The 33 Raptor engines on that super heavy booster, they generate a staggering 7,590 metric tons of thrust at liftoff. That is an insane amount of power. It's not just about getting off of Earth. It's about doing it with enough brute force to literally reshape our future. Now, to really, truly get what a leap this is, you have to compare it to the icon, the legend of the Apollo era, the Saturn V. Starship doesn't just beat it. It generates roughly double the liftoff thrust of the rocket that took us to the moon. We are talking about a completely different universe of power here. But all that power is useless if it's not cheap. The real secret sauce here is full, rapid reusability. And this is where it starts to sound like science fiction. After separation, the booster flies itself back to the launch pad, where it's literally caught out of the air by a giant pair of mechanical arms on the tower. This Mechazilla catch means it can be refueled and ready to fly again in hours, not months. It's just wild. Okay, so getting to Mars is one thing, but how do you get home? You obviously can't pack enough fuel for a round trip. The solution is something called in situ resource utilization, or ISRU. Basically, Starship's engines run on methane, and you can make methane on Mars using the CO2 in its atmosphere and the water ice under the ground. It's designed to live off the land. The final, critical piece of this whole transportation system happens right after launch in Earth orbit. To get that huge payload, we're talking 100 to 150 tons, all the way to Mars. The ship needs a full tank of gas. So after it gets to orbit, other tanker starships fly up and meet it, acting like an in-space gas station to top it off for the long journey ahead. Now, of course, a system this revolutionary, it doesn't just work on the first try. The path to getting here has not been smooth. It has been forged through a philosophy of fail fast, learn fast. And the results have been, well, pretty spectacular to watch. Just look at this timeline. The pace of development has been relentless. It started with those early high-altitude hops to try and nail that crazy belly flop landing maneuver. Then it moved on to the first orbital test flights. And now, with successful booster touches happening and multiple full-stock flights under its belt, the program is accelerating like crazy. Every single test provides tons of data for the next one. Along the way, this little three-letter acronym became a very common sight. For a while there, it felt like every other test ended in, well, exactly this. RUD. Rapid, Unscheduled,
disassembly. It's let's call it a humorous way of saying the rocket blew up. But here's the key. For the engineers, each RUD wasn't seen as a failure. It was a data point, a very fast way to find a flaw in the system, fix it, and make the next flight even better. So all this testing, all those explosions, all this incredible iteration, it is all in service of one grand, completely audacious goal: building a permanent, self-sustaining human city on Mars.
And the plan starts with robots, not people. You send the advanced party first, right? The very first Starships to touch down on Mars will be uncrewed cargo missions. Their job is basically to set the table. They'll test the landing system, roll out power grids, set up the equipment to prove you can make fuel, and land the first habitats. They're getting the place ready for the first human arrivals.
And when those humans finally arrive, we are not talking about a handful of astronauts in a tiny capsule. Each Starship is designed to carry up to 100 people. Just stop and think about that for a second. 100 colonists at a time. And with whole fleets of these things launching every 26 months when the planets align, you could see a population grow from dozens to thousands in just a couple of decades.
And here it is, the economic linchpin that makes it all possible. A normal, single-use rocket launch can cost hundreds of millions of dollars. Through this extreme reusability, the goal is to crush the cost of a Starship launch down to under $10 million. That is the disruptive price point that completely changes the game for access to space. It's what makes a real Martian economy, maybe even individual tickets, a plausible future.
Okay, it is very easy to get swept up in the vision, but let's take a breath and get real for a second. The path from where we are today to a city on Mars is still paved with some absolutely monumental challenges.
And I mean, this to-do list is daunting. That orbital refueling we talked about, it has to become routine, something that works every single time. The ship has to protect its crew from radiation for a 6 to 9 month journey. The life support has to be bulletproof when you're millions of miles from help. And then you still have to nail the fiery entry and landing on another planet. Every single item on this list is a massive engineering hurdle on its own.
And, this leaves us with one final and maybe most important thought. The rocket, it might actually work. They might solve all of those incredible engineering challenges. But the biggest question might not be a technical one at all. Starship can give us the ride, but are we as a species truly ready for the destination? Are we ready for what it means to live on another world? What do you think?